Welcome! In this series of short videos, we will look at topics common to both the PowerBasic Console and Windows compilers. Today we will look at how to use linked list collections within your applications. Today we're going to look again at collections under PowerBasic, supported both in the console compiler and Windows compiler. We're going to prepare a list collection. We can start this by declaring a local variable called listCollect. This is going to be declared as an ilink list collection, and we will set the class to be link list collection. As we've done with previous videos on collections, we're going to be using variants today to put data into and take data out of this collection. So we will create a local variable as a variant to contain our data. And our data is simply going to be a text string called test. There are a number of methods and properties with this particular class, but first of all we'll use the clear method to clear anything out of the collection. Now, since we've just created a collection, the collection will be empty, but it demonstrates the use of the clear method, so that at any point you can clean out a collection very easily with a single line of code. Simply by using the name of the collection, in this case listConnect.clear. We followed that with a message to our log to return the count of the number of items in our collection. Since our collection is entirely empty, this should return 0. So let's try running the application and see if we get that. And it does indeed return the value 0 for the number of items within our collection. So if we now want to put our test string into the collection, we can do that by using the add method. So that's listConnect.add, followed in brackets by the name of the variant which contains our data. And then we're going to write to our log again to count how many items are in the collection, which should now return the value 1. Which it does. So our data has now been added to the collection. So let's add another piece of data, and we will then attempt to pull information out of the collection. So we're adding a new string to our collection, and we're going to use a for next loop to pull the information out. So we've declared a local variable as a variant called item output, and we're using the for each construct to pull information out of our collection. So for each item output in the list collect. And we can push that out to the log by using the variant $command to turn the variant back into a string. If we run that now, we will see we're putting out to the log the two items we have in our collection, the string test and the string test2data. So from this construct, you can see it's very easy to pull all the information out of the collection using a simple for next loop. So since we now have two items in the collection, how do we go about inserting a new item between items 1 and 2? We can use the insert method with an index number. So we'll declare a local variable called index. We will set the value of that to 2, and we'll use the insert method to insert our new data at the second item position. This will take what is currently in item 2 and move it down to item 3. So our collection will now have 3 items in it, and the new data will be item number 2. As we're going to be pulling data out of the collection on a regular basis, within this video, I'm going to create a small macro that duplicates this piece of code. And we'll call this macro display list. We have used macros in some of the previous videos to make the code a little more readable and a little less verbose. What this macro will do at compile time is it will take all the code within the macro and put it into the main body of the application, and then the compilation will continue. So from a programmer's perspective, we merely have to put a single line of code in to get this information pulled out of the collection and sent to our log. However, I'll spend a moment looking at what we're doing inside this macro. We're passing the name of our collection on the parameters list. We're also using the macro temp construct. It's followed by a declaration of that variable as a variant. As we will be calling this macro multiple times within our function, without using macro temp, it would fail at compile time, as you are attempting to declare the item output variable multiple times. What macro temp does is each time it is called, it appends to the end of the name a 4-digit number, starting at 1 and incrementing each time it is called. This saves you, as the programmer, having to worry about this issue. So following that, we have a for each next loop. This is pulling information out of our list collect collection, putting it into the item output variable, which we're then sending out to our log. So we will simply take this single line of code, paste it in after our last commands, and this should send the information that's now in our collection out to the log. Let's try running that now and see if new data slots into the second index position. And there is new data in as the second item. Test2 data has been moved down to the third item. And our macro is working quite nicely to display what's in the collection. So having built up a collection of 3 items, can we now delete an item by index position? We can perform a deletion by specifying the index we wish to remove. In this case, we want to remove the first item in our collection. We're then calling the remove method, and we're giving it a parameter which contains our index number, in this case index number 1. This will remove the first item from our collection, and item 2 will become item 1. And we can then redisplay our list, which should now have 2 items. So we'll see that the first item, which was the test string, has now disappeared from our collection, and we now have only 2 items left in the collection. So it's very easy to remove an item by its index number. So having deleted an item, can we replace an item that already exists? We can indeed by using the replace method. Again, we set the index number, we use the replace, and we specify the index and the data that we want to slot into that particular index place. If we run the code now, you will see that the first item no longer is called new data, it's now called newer data. So we have successfully replaced the first item in the collection with some different data. When building up a collection, there is an index maintained for the next position, so that when you add an item to the end of the collection, it knows where to put it. So we can determine the current index by using the index property. So we can set the value of our index variable to the output from listConnect.index with a 0 in the parameters. This will tell us the current index, and we can pull out the number of items in a collection by using count. If we run that now, we will see the current index is showing as 3. The reason it is showing as number 3 is number 3 is the next available permission for new data to be inserted into. The number of items in the collection is 2, so the next free slot would be slot number 3. So let's add some more data to collection to make it bigger. So we've now created a for next loop. We're going to populate our variant with the string item plus the item number. So this will give us items 1 to 5, and we're calling the add method to add these to our collection. So if we run the code now, we should have 5 additional pieces of information added to the end of our collection. So there we are with 7 items on the collection now. So now we're going to set the index to the last position in our collection. So it should be sitting at item number 5. We can perform this quite easily by using listConnect.last. So we can set the index to the last item on the list. This will be the next free slot. Having set the index to the very last item, which is the next free slot, we can use previous to move back through the collection. So the very last item is going to come out, and then we're going to call previous again to get the next last. So if we run the code now, so we can see it's displaying the last item as item number 5, and the next last is item number 4. So we can step through the collection either from the beginning using next, or from the last entry using last and previous. So let's start from the other end of the collection and set it to the very first item. Easily done by using listConnect.first. We can then pull out the first by using the next command, and then the next one on the list coming out using next once more. If we run the code now, we will see the first item comes out as newer data, and the next as test2 data. So it has successfully moved the index back to the beginning of the collection. However, what if we wanted to pull the entry out of the collection by the index itself, rather than having stepping through from the beginning or the end of the collection? We can perform this by using listConnect.item followed in brackets by the index number. So in this case, we want the fourth item on the list. And there is our fourth item, which is item number 2, the fourth one in the collection. So far, we've been populating our collection using variants which are containing dynamic strings. However, you're not limited to just dynamic strings. We can also put arrays into our collection, as we've done with previous videos. So we'll now prepare an array and add this to our collection. So we are dimensioning an array with 3 elements, going from 0 to 2, as a dynamic string array. So we can then assign values to those 3 elements using the arrayAssign command. So we're assigning A1, B1 and C1 to those 3 elements within that array. We're then populating our variant by let item input equals and the name of our array. And just as we did before, we're using the add method to add that variant to our collection, just as we did with the dynamic strings. However, to output this to our console or to get the information out, we need to know that the variant coming back out of the collection is an array as opposed to a dynamic string. So I'm going to clone this macro and we'll call this new macro displaylist_ex. I've left the original macro in place so you can see how the code worked previously. So in order to support this, we're going to have to create some more variables to contain the data which is held in the array which is going to be coming out from the variant. So we're going to add to our macro temp list 2 additional values. One for the name of the array we're going to be using, and one for the for next loop count. And we will dimension those underneath. It's important that we dimension the array as a 0 element array. So as before, we're still using for each to go through each element within our collection. But we need to use the variant vt command to test the type of the variant which is coming out. This is going to be using the same construct we've used in previous videos for collections. We're using a select case statement to test the variant type. If the variant type is both dynamic string and array, we know it's a string array coming out from the collection. If it's just a dynamic string, then we can handle that as we've done before by sending the message out to the log using variant $, to convert the variant back into a string. So for the string array, we're using the let command to populate the array with the variant data. We can then use a for next loop, going from the lower bounding of the array we've just received to the upper bounding of the array. This allows it to work out just how big the array actually is. And for each item in the array, we're pushing the information out to our log. So now that we've created this macro, we can now call this after our collection has been added. So if we run the code now, we can see we're printing out to the log all the items in the collection plus the 3 items that are in the array. So we have successfully added both dynamic strings and an array to our collection. So in summary, what we've done today is we've created a linked list collection. We've shown we can count how many items are in the collection, we can add new items, we can insert items into the existing collection using an index, we can set the index on the collection to the beginning or the end of the collection, and we can use either the previous or the next commands to step through the collection one item at a time. We can quite easily step through the entire collection by using a for each next loop. and we've demonstrated the use of macros to save you time and tidy up your code. Hopefully you'll find this useful in your applications, but that's it for today. Thank you for watching.